In this video, we're going to be learning about the last three different types of chemical reactions and learning how we can identify them by looking at their chemical reactions. So the last reaction type that we looked at in the previous video was the single replacement or single displacement reaction. So naturally, we're going to start with something familiar by looking at what we call a double replacement, or we can also call it a double displacement reaction. So in a single replacement or single displacement reaction, we have one element replacing another element within a compound, but in this case, we actually have two different compounds that are going to be switching things around. Also, in a single displacement reaction, the reaction involved the switching of either the cation or the anion and not both, but we'll see in a double displacement reaction that the cation and the anion of one ionic compound switch places with each other. And this is easier to understand when we actually take a look at a chemical reaction. So if we look at the two reactants here, we see silver nitrate. So silver is in the first position, so we know that it is going to be the cation, and nitrate, which is a polyatomic ion, is in the first position or the second position, so it is going to be the anion. If we quickly check the charges, we can see that nitrate has a charge of -1 and silver has a charge of +1. So let's go ahead and write those in. Then here in the second compound, we see that we have two sodium atoms. Sodium has a charge of +1 because it's an alkali metal. And then we see another polyatomic ion here, which is a polyatomic ion that we call chromate. We can find this in our polyatomic ion table. If we look right here, we see that chromate has a charge of -2. So let's go ahead and write that in there. Now, what we want to do is we want to take the cations from both compounds and switch them like this, so that we're basically taking the two positive ion, or the positive ion from one compound, and exchanging it with the positive ion of the other compound, and that means that the cations and anions of each compound switch with each other. So if we deal with nitrate first, let's leave nitrate as our anion here. We see that nitrate has a charge of -1 and sodium has a charge of +1. So that means we only need one sodium for every nitrate that we switch places with. So sodium nitrate is our first product. Next, we know that chromate, this polyatomic ion, which has a charge of -2, is going to be our second anion, and the cation that's going to switch with sodium is silver. Silver has a charge of +1. Chromate has a charge of -2. So that means if we want to balance the charge, we need two silver ions in order to balance this charge, because +2 minus 2 is 0, so this is where we end up with silver chromate. So if we want to write a general formula for a double displacement or double replacement reaction, our first ionic compound we would call AB, or rather A is our cation and B is our anion, plus CD, where C is our cation and D is our anion. And if we know that A and C are going to switch places, that means that we're going to end up with CB, again, making sure that we have a cation and an anion, and AD, again, cation and anion here. So that deals with the general formula of double displacement or double replacement reactions. In the next type of reaction, which are what we call neutralization reactions, we're actually going to see something interesting when we look at the general structure. So remember from our pH video, we talked about what the word neutral means. Neutral means that we have a pH of 7, meaning that we have neither an acid or a base. So if we look at our reaction here, we see that our first compound has hydrogen here, which probably means that we're dealing with an acid, so we can put this in our general formula. And then we see that we have OH in the structure of our second compound here, which means that we're dealing with a base. And whenever an acid and a base react with each other, they undergo a neutralization reaction and make something that has a pH of 7. Now, there is only one chemical with a pH of 7, as we learned about, and that chemical, of course, is water. So that's why we call this a neutralization reaction, because an acid and a base neutralize each other. They eliminate the acid and the base from the compound, because if we take H plus OH, we get H2O, which is water, which is neutral because it has a pH of 7. And then the second product that we get here is some sort of salt, which is just an ionic compound here. So if we take the cation from the base, calcium, so if we remember where calcium is on the periodic table, we see it's an alkaline metal or alkaline earth metal, and therefore has a charge of positive 2. And the anion, in our case, that we're dealing with is phosphate, which has a charge of negative 3. So that means that we need to balance out the charges. So phosphate has a charge of negative 3, calcium has a charge of positive 2. The common factor between 3 and 2, or lowest common multiple rather, between 3 and 2 is 6. We can do negative 3 times 2 and positive 2 times 3. Negative 3 times 2 is negative 6. Positive 2 times 3 is positive 6. Positive 6 minus 6 is 0. So positive 2 times 3 means we're going to have 3 calcium ions, and then negative 3 times 2 means we're going to have 2 of the phosphate polyatomic ions like this, and there is our salt or ionic compound. So again, we call this a neutralization reaction because, of course, one of the products we get from an acid and base reaction is water, which of course has a pH of 7. But what we can see if we look more closely at the structure is if we call our acid AB, where phosphate, the polyatomic ion, is B, and hydrogen is A, and then if we call our base CD, where calcium is C, and hydroxide, the polyatomic ion, is D, we end up with, if we count here, we end up with CB, and then we would end, hydrogen plus OH would be AD, and this looks very familiar to our double replacement or double displacement formula, which means that based on the general formula, we can see that neutralization is also a type of double replacement or double displacement reaction. Finally, the most simple type of reaction to understand, although one of the more complicated to balance, are what we call combustion reactions. Now, combustion is just a fancy scientific word that means to burn, and we know that whenever we burn anything, we require oxygen, and we can see, if we look at our reactants here, we only have 2 different elements, carbon and hydrogen, and whenever we have element or compounds that are mostly based on carbon and hydrogen, these are what we call organic compounds because they are most commonly found in matter that is alive. So when we take organic compounds and when we burn them in oxygen gas, if we burn them completely, so this is what we call complete combustion, we only end up with 2 products because the reaction burns cleanly. We end up with carbon dioxide that is released into the atmosphere, and we know that this gas is a pollutant gas, but we also end up with water, although because the combustion reaction also produces a very large amount of energy. This water is not going to be liquid water. It's actually going to be water in the gas form, just like with carbon dioxide. So this is how a complete combustion reaction works. An organic compound is going to burn completely in oxygen in order to give us only carbon dioxide and water. But what about if we don't have enough oxygen? Well, if we don't have enough oxygen for this reaction to happen completely, this is what we call an incomplete combustion reaction. And incomplete combustion reactions are instantly recognizable because even if you can't see that we don't have enough oxygen, you'll see this horrible thick black smoke that is very dangerous for people to breathe. And the reason why this is here for an incomplete combustion reaction is that not all of our organic compound is converted into CO2. Some of it exists as carbon by itself, which is a very distinct black color, and other carbon forms this molecule called carbon monoxide, which is a highly deadly poison if we breathe it in. So an incomplete combustion reaction's general formula is very similar. We have an organic compound, something that came from a living organism at some point, plus oxygen. Only the main difference here is that we do not have enough oxygen for this reaction to finish, meaning that we don't only get carbon dioxide and water, but we also get carbon, which we can see in this black smoke, and we also get the deadly gas carbon monoxide, or any combination of these. Now that you've learned about the 6 different types of chemical reactions: synthesis, decomposition, single and double displacement, neutralization, and the 2 different types of combustion reactions, you're ready to learn how to balance chemical reactions, which is going to be the topic of the next video in this series.